Good morning and welcome to yet another Electron launch. My name is Max Muncy and I'm joining you from Rocket Lab Mission Control in Auckland, New Zealand. It's currently 9:06 a.m. on Sunday, July 5th here, but if you're watching from the US, happy Independence Day. What you see on your screens is a live view of Electron as it awaits its coming liftoff in 13 minutes from Rocket Lab Launch Complex 1 in Mahia. We've dubbed this mission Pics or It Didn't Happen in reference to some of the payloads on board this flight, and this is a special one as it will be Rocket Lab's lucky number 13th Electron launch. Our launch operations team has been working through the night to prepare for liftoff this morning at 9:19 a.m. local New Zealand time. Payload integration took place in the clean rooms at LC-1 in the days leading up to this mission before Electron was rolled out from the hangar down the 170-meter runway to the pad. Fueling with RP-1 in liquid oxygen has been completed, and coming up shortly, our launch director will conduct the go, no-go poll. This poll will confirm that the vehicle, satellites, weather, and range are all green for launch.
Okay, and all stations are currently proceeding with the go, no-go sequence. Stage, there you go.
Yeah, stages go.
Avionics.
Avionics is go.
FTS.
AFTS is go.
GNC.
GNC is go.
BMS.
BMS is go.
Beacon.
Beacon is go.
RF.
RF is go.
T1.
T1 is go.
GC. Go. BLS.
BLS is go.
RSO.
RSO is go.
MET. MET is go. MM.
MM is go.
LD sub.
LD subs go.
And executive.
Executive is go for launch.
All stations LD on mission. Go, no-go sequence.
Today's launch is headed to a circular 500-kilometer low Earth orbit at a 97-degree inclination and is carrying 7 satellites on board Electron. Our mission partners include Canon Electronics Incorporated, whose payload was procured by Spaceflight. We have several small sats from Planet, which operates the world's largest Earth observation constellation. And finally, we have In Space Missions, a British small mission management company. Canon Electronics spacecraft is called CESat-1B, and its objective is to test and demonstrate Earth imaging technology they've developed ahead of producing the microsat for future missions. This launch will be the second time Electron has ferried satellites to space for Earth imaging company Planet. Planet launched their Dove spacecraft on board Rocket Lab's second Electron launch, the STILL testing mission, back in 2018. This time, Electron will carry 5 of Planet's latest generation satellites to space, the Super Doves, where they will join the remainder of the flock already in orbit. The final payload for this mission is the Faraday 1 6U CubeSat from In Space Missions, which is carrying experiments from 7 of their customers as part of the company's hosted payload service. Faraday 1 is the first of a series of satellites from In Space Missions providing services for research organizations and commercial customers, including Airbus Defence and Space, Lacuna Space, the Space Environment Research Center in Canberra, and more. These customers are testing a range of technology concepts from 360-degree optical video imaging to radio frequency spectrum monitoring. Each of these 7 payloads will be delivered to precise orbital insertions by Electron's third stage, which is called the kick stage, and that will fire its Curie propulsion system approximately 50 minutes into flight after separating from the second stage. Our broadcast will end just after separation of the kick stage, so we won't be showing payload deployment, but check in on Rocket Lab's social media channels for confirmation of deployment in about an hour's time. So here at Rocket Lab, we are no stranger to having a little bit of fun with our mission names, and we're continuing that tradition today. The name Pics or It Didn't Happen makes reference to the payloads on board, all of which are Earth imaging smallsats. The patch pays homage to the viewfinder of a camera, while the settings around the border are linked to various aspects of the flight. The 540 on the far left is the approximate number of seconds before Electron reaches orbit. And we've got 7 payloads on board the vehicle. -3 is the number of seconds into the countdown when Electron's 9 Rutherford engines on stage 1 ignite. And 500 is the number of kilometers above the Earth's surface this mission is targeting for a circular orbit. Our patches are applied to each fairing before launch, so if you look closely, you should be able to make it out.
Stage 1 and Stage 2 high voltage pump lips have passed, and engines are ready.
Stage 1 and Stage 2 high voltage batteries ready for flight. Avionics terminal checks complete.
Copy all avionics on stage, thank you. NGCLD on mission.
All day.
Yeah, please proceed with sequence 47, pad ready for launch.
Sequence 47 in work.
So this is one of my favorite views of our launch site, showcasing the Mahia Peninsula. In the left foreground, you should be able to see the road leading down to the launch facility. In the background, you have Portland Island. This view is roughly 3 kilometers away from Electron, near Rocket Lab range control. Today's flight will be Electron's 13th overall launch and the second since COVID-19 restrictions were lifted in New Zealand. Flight 13 also marks our fastest turnaround time between launches, as it was only 3 weeks ago that Electron launched from this same pad at Launch Complex 1, carrying an educational smallsat for NASA, a technology demo for the University of New South Wales, and 3 payloads for the National Reconnaissance Office. While the launch team were preparing the Flight 12 vehicle for liftoff, our vehicle integration team at the Auckland Production Complex were prepping the first stage of Flight 13 for shipment down to Mahia. In recent years, we've been focusing heavily on building up rapid production and launch capabilities for our Electron rocket. Right now, the team rolls a complete vehicle off the factory floor once every 18 days, all in pursuit of our ultimate goal to launch weekly missions in the near future. Rapid production is only useful if paired with rapid launch capability, however, but we've got that covered as well. Rocket Lab's privately owned and operated Launch Complex 1 is able to support up to 120 missions a year. A second launch pad is currently under construction at the New Zealand site and will be online by the end of 2020. Our third launch pad in the United States is located at Rocket Lab Launch Complex 2 on Wallops Island in Virginia. We'll be launching our first mission from home soil before the end of the summer, and it will be from this same pad where we'll launch Electron to the moon for NASA's Capstone mission early next year. These launch pads and flight opportunities are all part of our vision to open access to space for small satellites and make convenient, frequent delivery to space easier than ever before. Right now, we're at T-minus 5 minutes and counting, and all systems are nominal as we count down to liftoff. If for any reason we need to scrub today's launch, we have daily launch opportunities within the same time window in the days ahead. Now, you'll no doubt have heard that our team is working towards converting Electron into a reusable launch vehicle. Our chosen method utilizes a helicopter, which will catch the first stage from the sky as it descends underneath a parachute. We're not conducting any recovery testing on today's mission, but work is continuing behind the scenes as the team prepares for the first return of an Electron booster. It's something we're really excited for and a huge step forward in our overall goal of making frequent, reliable launch a reality. We're targeting our 17th Electron launch for the first attempt, and we're at Flight 13 already, so we'll be at 17 in no time. So with just 4 minutes left on the clock, Electron is moving into the final stage of the countdown. At T-minus 2 minutes, the rocket's internal flight computers will take over the countdown before Electron's 9 Rutherford engines ignite at T-minus 3 seconds. So we're going to hand you over to the operators in mission control to listen in to the final moments before launch, and we'll check back in with you shortly after liftoff.
All stations, this is LD on mission. From now on, there should be no red flags in your LCCs. Beacon, please confirm flight computer as goes green.
All as goes green.
Beacon, please lock auto sequence and confirm.
Auto sequence locked.
All stations LD on mission, we're currently go for auto sequence start at T-minus 2 minutes. And I can confirm LD is go for launch.
Vehicle is on internal power.
Pressing locks.
Locks load is complete. System is in recirculation. Anti-gathering
Pressing
disabled.
Kuro.
Stage 1 and Stage 2 are pressed.
High flow engine purge enabled. Water deluge is active.
Re-readying engines.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Stage 1 propulsion is nominal.
Discharge is nominal.
We're at T plus 45 seconds into flight, and we've had a successful liftoff from Pad A at Launch Complex 1. Next up will be Max Q, which is the point when the rocket is under the maximum amount of aerodynamic stress during its ascent.
Vehicle is supersonic. Approaching max Q. Pass through max Q.
There's that call out from the team in Mission Control confirming Electron has passed through Max Q. Coming up are 3 events which will occur in close
AOS
proximity.
at Chatham
First, the
Station.
9 Rutherford engines will power down on the first stage, commonly known as main engine cutoff, or MECO,
Guidance is
before
nominal. 30
stage 1
seconds
and
remaining.
stage 2 separate. Then the
Stage two
vacuum
propulsion
optimized engine
is
on stage
holding
2 will
nominal.
ignite as the vehicle continues onward.
Entering stage 1 burnout detect mode.
And MECO confirmed.
Stage separation selected.
Stage 2 mission.
We've had a clean stage 1 and stage 2 separation. Electron is continuing on nominally. You can see the nozzle on that second stage engine beginning to glow as it makes its way to orbit. And we're now at T plus 3 minutes, with fairing separation coming up in a few seconds.
Fairing jettison.
And there goes the fairing. You've just seen it flying away from the vehicle there. The payloads are now exposed, ready for deployment.
Stage 2 propulsion is nominal.
As you can see, we're continuing to climb at 9,500 kilometers per hour, and Electron is currently at 140 kilometers altitude, and it's above the Earth on its way to orbit. And one of the perks of the job, we've got an incredible view of the Earth below us. We're now 4 minutes into flight and Electron is continuing to look good. We've got a couple of boxes left to tick off ahead of kick stage separation, those being battery hot swap and second engine cutoff coming up shortly. Electron is soaring to space at a speed of 10,900 kilometers per hour.
Stage 2 propulsion is nominal.
Now in about 90 seconds time, Electron will perform its battery hot swap. The pumps on the Rutherford engine are powered by batteries, and once these have been depleted, we swap power over to a new battery, allowing us to save mass on the way to orbit.
Guidance is nominal. 200 seconds remaining. Altitude is 190 kilometers and the speed is 3.8 kilometers per second.
HV battery discharge nominal. Approaching hotspot, roughly 30 seconds.
Okay, all stations on mission coord. Initiating the SAP response plan.
So as you can see, Electron is at 13,700 kilometers per hour, is 191 kilometers above the Earth's surface as we're waiting for battery hot swap. At this time, it looks like the signal for our video feed has become too weak to receive. However, we are still receiving good telemetry from Electron. So we're going to switch over to mission control and we'll provide updates throughout the rest of the mission.
Stations on mission control.
This is Mission Control in Auckland. It appears we have lost our video feed for today's mission. Without these beautiful views from launch, we're going to end today's webcast here, but stay tuned to social media for our updates. Thanks again for joining us for another Electron mission.